All right, we are going to do the law of cosines in area. So I have the formula written out here, and you can see I drew in some arrows to really, I want to stress a couple of things here. But the formula is just c squared is equal to a squared plus b squared minus 2ab cosine c. Now there are a few different forms of this formula, and I think all three of them are probably able to be found in your book. But the important thing is that the side of the triangle that's by itself over here on the left and the angle that's inside of that cosine are a pair. And so this could be a squared and a. We have c squared, it could be b squared and b. But then obviously if you say had a squared here and capital A there, these a's here would turn into our c's. So they are kind of interchangeable, but the important thing is that these two have to match. And that's how you're going to kind of know which way to set it up. And so that's for just a triangle like this one. So I have here an example, and this is a side case. We have three sides. We don't have any angles. We're actually asked to find an angle for this one. Now, if you remember in the last section, we needed a pair. We had to have both an angle and a side somewhere in our triangle to make the law of sines work. Here we don't have a pair. We have three sides. That's where the law of cosines comes to the rescue. Now, once we do it once and find this first angle, and we'll go through what I did here in just a second, but once we do that, then if we need any other parts of the triangle, you probably should switch to the law of sines. It's easier to use, it's smaller, it's less complicated, less messy, fewer mistakes available there to make. So let's look at what I did. So I wanted to find angle B. That means that in this formula, I don't want angle C, I want angle B. What that tells me is that I should have a b squared here. So you'll notice I put b, my 8.8, on the left and have it squared. And I have angle B, which means that these guys have to be A and C. A and C, and again A and C. So I squared all the pieces that needed to be squared. That's where I get my 77.44, the 36 and the 144. 2 times 6 times 12 gave me 144. And now I'm going to combine my like terms. 36 and 144 make 180. Now notice I didn't combine the 180 and this minus 144 because this 144 is attached to that cosine. They're not like terms. You can't put them together, so please don't. All right, so I subtracted 180. That's where I get this negative 102.56. I divided by my negative 144. And so now I have this, the cosine is equal to 0.71. And so if I flip it around and use an inverse cosine, the inverse cosine of that 0.71 is my angle B. And in this case, since we're working with a triangle, we're going to make sure we have our calculators in degrees, and we get an answer of 44.6 degrees. So this can be used to find an angle when you have three sides. It can be used to find something else if you have two sides and an angle in between, the side angle side case. But finding an angle tends to be the trickiest bit that happens with this. It's just messy. That's really the big key here. And you have to be careful with it. That's all that we really have to watch out for with this. So, all right, I'm going to change the board. All right, so we're going to continue on. We have an area problem. So we're all hopefully familiar with how to find the area of a triangle. It's just 1/2 times the base times the height. What happens if you don't have the height? So that's what we're going to look at. We're going to look at two different ways to find area, and so here's our first one. So we have our triangle, and we have two sides, A and B, and we have the angle in between them. Okay, that's what we're given. Two sides and the angle in between. So notice I don't have the height of my triangle. Okay, that I wrote it in there, but we don't actually have it. So if you think about the formula for area of a triangle, 1/2, oh look, there's a half, times the base, well my base is B. So I have an A sine A and a sine C where I would normally have a height. Here's the kicker. The sine of C is equal to H over A. And so if you solve that for H, you get H is equal to A times the sine of C. So anyway, if you have two sides and the angle in between, this is the formula that we're going to use for the area. Again, the letters are interchangeable. This could be B times C with the sine of A. But the important thing is you need to have two sides and the angle that's in between. So all three letters should be represented. So I did one example. Here we go. We have angle A, and we have sides B and C. A is 70 degrees, B is 10 feet, and C is 30 feet. So I want to find the area. I fill in my numbers, 10 and 30 and 70. And 1/2 times 10 times 30 is 150. And then I just type it in my calculator, and out pops 140.95. So this is one way we can find an area. We have two sides and the angle in between. Next up, we're going to look at what happens if you just have three sides. All right, and here is our second formula for finding an area. This is for the side case. So you have three sides of a triangle, just like this one over here that we're going to do as an example. So this is called Heron's formula, and the area K is equal to the square root of S times S minus A times S minus B times S minus C. And I'm sure you're all wondering, what in the world is S? S is equal to 1/2 times A plus B plus C. So here's how you're going to want to do these. Start by finding S. Okay, do that little bit of work, and then go back and find your area. So for my triangle over here, I have sides of 10, 8, and 16. So for S, I do 1/2 times 10 plus 8 plus 16. And as you can see, I added it up. We got 34. 1/2 times 34 is 17. So my value for S is 17. Once I find S, I can go ahead and use my formula for K. So you'll notice I have a bunch of 17s in there. And then I have my three sides. By the way, it really doesn't matter what order they're listed in here. But I do my subtraction. I get 9, 7, and 1. You multiply all that together, you get 1,071. And the square root is about 32.7. So there you go. That's Heron's formula. So this was a nice little section. That's really basically the whole thing. The law of cosines and these two area formulas. So enjoy.